we are going to get started. The microphone is working today quite loudly. Okay. All right. So today we're going to talk about some research methods. But first, let's talk a bit about the exam. Our first exam is Thursday. So for those of you registered, you can take the exam. If you're not registered, you cannot take it. We won't grade it. For those of you who are registered and don't feel like taking an exam, you just got into the class yesterday, that's also fine, because remember, you get to drop the lowest score of your first 3 exams. So if you just got enrolled in the class and you're not ready to take an exam, fine, just drop this one. You do want to bring the Scantron. This is what it looks like. In reality, that's my phone picture of it. That's a little dark, but this is the one you want. It's red. You want to fill in your name and your Berkeley ID number, color in the circles, and do that on both sides, front and back. It will be a great time saver for you if you do that before class. If you have to spend valuable time filling that in, it'll just take up a lot of your time. This test is 40 multiple choice questions. No essays, no short answer, no nothing. It's all multiple choice. It'll be the only test that'll be all multiple choice, but nevertheless, that's what this one is going to be. Now, before I get into some more details of the exam, one more announcement. The APU, the Association of Psychology Undergraduates, is having their first meeting today, 6:30 p.m. in 3105 Tolman, also known as the Beach Room. So Nobuko and Michelle, you guys stand up. They are around if you have any questions. There she is. She's down here. So check that out, Association of Psychology Undergraduates. All right, now back to what's happening on our exam. These are in the slides that are posted on B-Space, but just to clarify for you, this is the stuff that's not going to be on the exam, and then I'll turn to what is. So these are things you don't have to know. In the little clinical case boxes in all the chapters, Jose, you remember the little boxes, you don't have to know those. You do not need to know focus on discovery box 1.3. You don't need to know the distinct and separate defense mechanisms that are in that table. You don't need to know any of the focus on discovery boxes in chapter 2. These are, when I say you don't need to know them, I mean they're not going to be tested on the exam. I would, of course, love for you to read them. They're informative and stuff, but I'm not going to ask you any exam questions on them. And you don't have to know like neurotransmitter names. I'm not going to ask you about GABA or norepinephrine, serotonin, dopamine, those sorts of things. Other stuff that's not on the exam, in chapter 3, you do not need to know all the names of the scales of the MMPI. There's a table, 3.6, that takes up an entire page. I'm not going to ask you about the names of all the scales. I'm not going to ask you about all the chapter names in the new DSM-5. That's also another table that takes up a whole page. And in all those details and numbers from the tables, I'm not going to ask you about that. I'm not going to ask you that kind of detail about what's the prevalence rate for avoidant personality disorder. Anything that's in the table, I'm not going to ask you about. And then in chapter 4, which we'll talk about today, I'm not going to ask you any questions from the focus on discovery boxes there. And again, the details and the numbers from the tables in that chapter. That's kind of a universal that I won't ask you details and numbers from tables on any exam. So I just ruled out a number of things. These are things that won't be on the exam. So useful, but what will be on the exam, perhaps even more useful. So from chapter 1, I want you to know the characteristics of stigma, the different definitions of abnormal, conceptualizations of mental illness throughout the course of time, how they change, basically the history. I do want you to know some of the names of key figures in history and what they were known for. Something about the mental health professions. Notice that some of these things that I'm putting up on this list, we didn't talk about in class. And so unless I explicitly tell you it will not be on the exam, you can assume that it will be. So there's plenty of stuff in the book that I will not be talking about in class, and I do that on purpose so that I'm not redundant with the book. So that doesn't mean it won't be on the exam. So mental health professionals is one example of that. We didn't talk about that in class. In chapter 2, I want you to know the key paradigms, the nuts and bolts of what are the essential aspects. So what's the difference between a SNP and a CNV in the genetic paradigm? What are the different areas of the brain? That would be something to know for the neuroscience paradigm. What are some of the key constructs that are studied in behavior and cognition in the cognitive behavioral paradigm? Also those things that cut across the paradigms, emotion, sociocultural factors. I want you to know those sorts of things. And in chapter 3, I want you to know about the different kinds of reliability and validity. You will be getting, is that right, a kind of a summary of the different kinds of validity in section, or you already did? Did you do that? You talked about it in section. So you do want to know those different kinds of reliability and validity. You want to know the key changes in DSM-5. You don't not all the names, but what are the differences in DSM-5 compared to the earlier editions of DSM? You want to know the different assessment methods, interviews, and the projective tests, the objective tests, neuropsychological assessment, brain imaging. You want to know about all those kinds of assessment methods and tools. And then you want to know from chapter 4 the different research methods, what they can and can't tell us, and then the different parts of research articles, which is what we'll go over today in class. So these slides are posted on B-Space with all of this information, so what you do and don't need to know. And here now are some sample exam questions. And so for these, I've enlisted the help of Janelle, Mike, and myself to demonstrate to you the correct answer. All right, so here is what you can expect to see with respect to multiple choice. Are we in order? I have to kind of stand up over here. So Janelle is A and B. Mike, what do you got? C and D, and I'll be E. All right, so here we go. All right, so here we go. This is a sample question from the stuff that would be covered in chapter 1. All right, so who do we think here? Correct. Okay. Here we go. Here's one from chapter 2, the genetic paradigm here, asking about the construct of heritability. So well, it can't be me. So who do we think has the correct answer here? Nice interpretive dance there. Very good, Mike. I want to see that from you as well. Right, here we go. Here's another one. Okay, here's something that we covered in lecture when I did the ocean moon word learning experiment. What was the purpose of that? To A, kill time, B, make you laugh, C, no, those aren't the answers. So what do we think here the correct answer is? That is correct, Janelle. Not all the correct answers on the test will be B. Just a little tip. That's just how it happens around here. Okay, here we go. Here's something about diagnosis. Beginning with DSM-3, one important change was implemented. All right, here we go. Oh, well, okay, so how many people, I heard some C's for Mike there. I heard some people say some B's. I heard some A. I'm hearing everything here a little bit here. That's right, people. That is right, okay. Now, here's another one dealing with assessments. This is a good example question because this requires you to not only know this stuff, but apply it. And a lot of the multiple choice questions are like this. Application of the construct, figuring out what I'm referring to with the question and then appropriately applying it here. So if we're doing an assessment, what would be the correct tool here? Who do you think? That is correct, okay. And here is another one, this is what we'll talk about in class today, about a part of a research article that covers the key findings and implications of the study. C, I hear. Anybody else? A? Oh, we're torn here between A, Janelle. Is it Janelle? Or is it Mike? It is Mike. Yes. Okay. Thank you. Janelle's the only one who did the interpretive dance, so well done. Okay, so let's talk about some research methods. First, some 3 key things to keep in mind as we read research in the textbook, and you're going to read research in section. 3 key constructs that I want you to remember, and I'll break them down for you. Testability, replicability, and generalizability. So These are the cornerstones of research, not only in our field of mental illness, but any field. Let's break them down a little bit. Okay, so the first one, testability. Can you test it? So a theory or an idea about what might be causing mental illness or what might actually be a mental illness or how we might treat a mental illness is only as useful as it is if it can be tested. So I might have a theory or an idea about a useful treatment for panic disorder. People who have panic attacks might be for people to hold their breath. Now that sounds ridiculous, doesn't it? Yes, it is ridiculous, but we could test that. We could randomly assign some people with panic attacks to a treatment where I train them how to hold their breath, and then we can have a control group where we give them a better treatment, and we'll see, we can compare them and see what works. That ridiculous idea, but yet it's testable. Here's another ridiculous idea. I could have an idea or a theory about what's causing people with schizophrenia to hear voices is that they have a little person on their shoulder whispering in their ears, and those are the voices that they hear. Okay, a ridiculous idea number 2 for today. This one is particularly bad for research, though, because I can't test that. I can't measure this invisible little person on my shoulder whispering in somebody's ear, because it's invisible. There's no way to test that. So if you can't test an idea, a theory, something about a treatment, if you can't test it, it's not a good idea, and it's not welcome in the world of research in mental illness, or really in the world of research on anything. So the idea, the theory, the hypothesis, you must be able to test it. And that sounds obvious and intuitive, of course, that makes sense, but sometimes things that make good sense are very difficult to test. Why is it that some people have bad dreams, for example? Well, dreams are a difficult one to test, aren't they? How do we know if someone's dreaming or not? Well, we could measure some EEG, but does that tell us if somebody's dreaming? It doesn't tell us the content of their dreams. We have to rely on people to tell us what their dreams are. So we could possibly test that, but what if people can't remember their dreams? So being able to test some things is more difficult than it may sound sometimes. I gave you a couple of really easy and ridiculous examples, but it really is the cornerstone of good research. You've got to be able to test it. All right, what's the second idea here is you've got to be able to repeat it. So what does that mean? Well, if I find in my research that people with schizophrenia don't show very many outward expressions of emotion, and I have found that in my research, doesn't mean anything if other people at other universities, say people down the road at Stanford or out the University of Illinois or the University of Geneva in Switzerland, if they don't find the same thing, if they don't replicate what I find, it calls into question whether or not my finding is actually something that's real, or if it was just a statistical fluke. So somebody wrote about this in one of the biggest journals in all of science. The actual journal is called Science, and that publishes some articles from our field as well as all aspects of science. And this guy used to be the editor of Science, and he said, what makes any scientific finding a worthy finding is not who did it or where they were, the prestige of the university, how much funding they had. No, none of that matters. The worth of it really matters if that finding can be replicated. So as science progresses, we begin to believe in findings if more than one research team comes up with the same result. Replication is very important. And the New York Times had a little blurb in there. Now you can see all over the place on websites and newspapers and popular media just little blurbs about science. I'm going to read you some of them today, in fact. And this article was cautioning against the perils of this little bite-sized science. Anytime somebody has something super exciting, some new finding, it gets a lot of media attention. And that's really sexy and exciting. Oh my God, that's super newsworthy. But then if 10 other people don't find that same result and replicate it, those things unfortunately don't get the news, the little blurb at the top of the feed on Gawker or anything like that. Nobody cares about that. But we as a science and you and people as consumers of science really ought to know if you can believe a finding, the best way to believe a finding is whether or not somebody else has found the same thing. So we need to be able to replicate it. And then the third thing is, does it generalize? Okay, so let's say I'm going to do a study of puppies, golden retriever puppies, because they're the cutest puppies there is. But then I might want to know, well, if I do a study on one puppy, that's called a case study method. One of the problems with the case study is it doesn't generalize. And you want to know, does it generalize to a whole group of puppies if you're just starting with one? But then you don't want to know if it's, what about if it's something specific to golden retrievers, does it generalize to other puppies? Like, what about corgis? They're also super cute, and so I want to know, do my findings, generalize there? But not only that, what about if I want to know, is it not something specific to puppies, but does this generalize to adult golden retrievers? And not just golden retrievers, but what about all dogs? So you want your findings to generalize. And we don't usually in our field do studies with puppies. I was using that just to illustrate, and they're awful cute. But a lot of times we do studies, and you all are participating in RPP, where you're in studies. So we've got a group of studies going on here at Berkeley with college students at Berkeley. So the results of our studies here with college students at Berkeley generalize to studies that are done at Stanford with college students. They're kind of a snooty private school. We're like a real school with a... I just say that really for the podcast, in case there's somebody from Stanford listening. No, but does it generalize to other universities in the Midwest, or do our findings generalize to people who don't even go to college? And what about people that live in China? Does it generalize beyond our culture? So generalizability, another word for that is external validity, is an important part of research that we want to make sure our findings generalize beyond just the one sample of one puppy or one group of college students or one group of people in the United States. Another important part of science. So the three things to think about as we read through research here: is an idea testable? Has it been replicated? And does it generalize? And if particularly any study that we read kind of falters on one of these, we just want to take a little bit of caution when we're interpreting those. All right, so let me just talk about a couple, or actually just one. I'm going to only go over one kind of research design here. I want you to know the other designs that are talked about in the book, the case study epidemiology. I'm just going to talk to you about correlational designs, because these are sometimes confusing for people. So I just want to make sure you understand the ins and outs of these methods. So correlational studies will typically report the statistic that they will report often is a correlation coefficient. A correlation coefficient can range from a negative 1.0 to a positive 1.0. So as you look up here, these are two pictures of perfect correlations. They're both 1.0. The one on the left is a positive 1.0. The one on the right is a negative 1.0. When you're interpreting correlations, there's two things to keep in mind. First is the magnitude or the size of the correlation coefficient. So a 0.25 versus a 0.85. The closer the number is to 1.0, the stronger the correlation is. And what's the correlation? The correlation is really the association between two things. So what's the correlation between shoe size and IQ? Well, I don't know. I just made that up. It's probably not very high. Probably closer to 0.25. Probably not very high. Probably not the bigger your shoe size, the bigger your IQ. But what is the correlation between body mass index and obesity? That correlation is probably closer to 0.85. The larger someone's body mass index, the more likely they are to tip into the range of obesity. So Body mass index, obesity are more tightly correlated than shoe size and IQ. The magnitude tells you the strength of the relationship between two things. Now, the other thing about a correlation is the direction of the relationship here. Positive or negative. And it's really an independent domain interpreting correlations. And this is perhaps where it gets confusing, because sometimes people mistakenly assume a negative correlation doesn't necessarily mean a strong relationship, but it can be. The negative correlation here is illustrated in the top panel there on the right. It's not really, well, it's also illustrated here in the middle panel on the bottom. A negative correlation, if you've got two things that you're looking to see what the relationship is between them, and let's say what we're going to now look at is sugar consumption. I don't know why I'm on diet today. Sugar consumption and pant size. All right, that's probably a positive correlation, actually. I'm trying to think of that would be the more sugar you consume, the larger your pant size. Okay, let's go with this vegetable consumption. That'll probably work, and pant size. The more vegetables you consume, the smaller your pant size. That would be an example of a negative correlation. The more vegetables you eat, so a high number on that variable, a small number on the other variable. So eating 7 servings of vegetables a day is probably correlated with being able to wear a size 2 or 28, if you're a man. I'm completely making this up. I have no idea if that's really true. It just makes common sense. But just to try to illustrate what the direction of a correlation means. So 2 different dimensions, the magnitude, how big it is. You can have let me just give you an example. If you have a correlation that is a negative 0.72 and a positive 0.59, what's the stronger relationship? The negative 0.72, right. Even though it's negative, the strength of that relationship is stronger. Okay. Now, one of the things, does correlation mean causation? No. And I think you can, if you want to be technical about it, you could say not usually. But it's better to just remember no. I mean, there are certain kinds of correlational designs where you can come closer to determining causation, but they're very complicated designs and not the ones that we're going to be dealing with here. So, the better answer is just to remember no. Correlation doesn't mean causation. Only under a very refined set of circumstances can you make any inferences about cause. But yet, there are popular bite-sized science things that pop up in the news all the time that suggest cause. So here's a headline, eating fish may ward off dementia. So this was a little science thing in the New York Times. So if people eat a diet rich in fish, it's good for the heart. The new evidence suggests that such a diet may ward off dementia. Ward is an action verb. I'm just going to dip into grammar for a moment here, suggesting that if you eat a lot of fish, it will keep you from developing dementia. And so, but really, if you read the details of this particular study, it was a correlational study. So what they found was that fish consumption was the more fish people consumed, the less likely people were to have developed dementia. It was a correlation, even though they used that term, may ward off dementia in the title. Here's another one. TV reduces adult-child conversations. And I'm taking on the New York Times today. Here's another one there. TV reduces, holy cow, I mean, if kids and their parents won't talk, I'm just going to turn off the TV. If TV causes kids and adults to talk less, we should just get rid of TVs. But no, it doesn't. It sounds like it, and that's what this headline says. I know you can't see it up there, but TV reduces adult-child conversations. But if you read this carefully, what they found was the amount of hours people spent watching TV was associated with, that's another word for correlated with, less conversation between adults and children. That's a good example of a negative correlation, more TV, less conversation, but it's not cause. I mean, it could be that kids and adults who don't talk very much, I'm bored, what am I going to do? Let's turn the TV on. Right? Less conversation could cause more TV watching. You've got a particularly silent family member, we just don't talk much, we just kind of one word back and forth, and we watch a lot of TV. So the problem with these sorts of things is in correlations and determining whether or not something causes is the direction could go either way. It could be that not talking very much in the home is what causes people to watch TV more. It's a little harder to think of how dementia could cause people to eat less fish, but you never know. I mean, it could happen. The point here is correlation, you can't infer causation. So when you're reading these little bite-sized blurbs about science, pay attention to the headlines and look closely at the words, because anytime an action verb is in there, it's suggesting a cause. It's probably not there. Most of the studies that we're going to be reading about this semester are correlational in nature. And one of the main reasons why we're going to be reading a lot of correlational studies, at least when it comes to understanding the symptoms and the causes of different mental illness, is that you cannot have one of the key aspects of what makes up for an experiment. So if anybody's read ahead, what are some of the things that would distinguish an experiment from a correlational design? Okay, so you manipulate a variable in an experiment, which is true, but you can also manipulate a variable in a correlational study, so that doesn't completely distinguish them. What's another aspect, yes, back in the back of an experiment? Randomly assort, or another word for that is randomly assign. That is correct. You cannot randomly assign someone to have schizophrenia or not. You can't randomly assign people to groups because they have the illness or they don't. And so studies of whether we're talking about schizophrenia or alcohol use disorder, ADHD, we're not randomly assigning people to these conditions. So we cannot. So right there, we're not doing an actual experiment because we cannot randomly assign. Now, when it comes to studies of treatment, however, here's where we can do experiments. So let's say we wanted to test a new treatment for depression. We could start with a group of people who all have depression. Let's say we have 100 people. We could randomly assign 50 of those people. And by randomly, I literally mean you could draw names out of a hat. There are probably there are easier ways to do that. But randomly pick 50 out of your 100 people and put them in treatment A, and then the other 50 people go into treatment B. Then we can test whether or not one treatment is more effective than another because we've randomly assigned. So when it comes to treatment studies, we can have random assignment. But when we're looking for the causes of something, that's where most all the studies that we'll be talking about are going to be correlational. That is random assignment. So she asked, how can you manipulate variables in a correlational experiment? So let me give you an example. So we can't randomly assign people to have schizophrenia, but what we could do, and we do this a lot in our own research, we can have a group of people with schizophrenia and a group of people who do not have schizophrenia, and we're very interested in their emotional responses. So maybe what we'll do is we'll show them some emotionally evocative films or some pictures. What I'm manipulating in that